for this quiz 2, I have already uploaded as a file in the general section. It is a file. It is not your like your any other assignment or any other display. So it is like a file. So if anybody has got question regarding my quiz 2, I am here to help. Let me discuss that solution. There is some problem for writing 25. I have by mistake I have written 0.25. So in the question it was written 0.25 in some cases, that is 25, and one of the 0.25 will become 50. So that way the question was modified, e to the power 0.25 minus 0.25 or e to the power minus 25. But that will not change the answer. Answer remains the same except for the question number 5, which I have given in the solution manual. Any confusion, I can display that and discuss with you. What is your opinion, students? Quiz number 2, any question? It seems they are not there. So anyway, I will take up this discussion about the quiz 2 questions later on at the end of the class, because right now we are not ready with your questions, it seems. You can see the file loaded in the general section. File name is EC353, EC353 quiz 2 solutions. Okay, I repeat, file name is EC353 quiz 2 solutions. So you can see that your doubts will be clarified. I have given the solution, not only the answer, and you check your answers. If somebody has got any doubt, I can discuss in the end of the class, or maybe few minutes I'll give you on Friday also to talk. Whatever is convenient, I will go according to that. So now I am starting module number 3, for which I told you that the due date for the quiz 3 exam will be 3rd March. It may be extended by 1 week end, but I am not sure. I will go by March 3rd as the examination date, so you prepare according to that. Today I am starting, and up to 20th February it will be taught for quiz number 3, for your module number 3, which will be the part of the quiz number 3. And on 1st there is no class, on 2nd there is no class. So on 3rd I am expecting your quiz 3 exam. If not, I will extend it by 1 day or maybe by 1 week end. That depends upon the discussion that comes up from the student side. Okay, anyway, students are very few since they are shifting, so that's why this is there. Module 3 is for multi-vibrators. So what is the meaning of multi-vibrator? And it will be once again related to our switch that I have talked earlier, in which a capacitor charging were also coming into picture. Now that concept of capacitor charging will be used here in the switch. Automatically question comes, why this capacitor should be there in the switch discussion? That will be used in this discussion of module number 3. So because of shifting, your friends are not there, you can help them by passing your notes to them. Okay, so I take the presentation. I'll talk about the switch. You prepare your questions regarding your quiz number 2. I welcome today, and maybe I'll take it up tomorrow also, as per your convenience. I'm going for the presentation. Yeah. I'm here. You can see the slides. I'm writing something on my tablet. You can see that, okay? Fine. So when we talk of a switch, what happens? This is a switch. Here is some signal coming. When the switch is off, this V naught, I want to see. Suppose switch is off like that and it becomes on here. Between 0 to T, it is on, otherwise it is off. So this is my switch voltage, switch state. During this period, this is your on and this is your off. So there are two states of the switch. We'll be focusing on these two states only. So switch state is on and off. It is on between 0 to T. It becomes off after that. Before that also it is off. So what is my V naught? V naught T will be 0. At this point, it will be something like that. This is your VIT. When the switch becomes on, it is your VIT. It is your 0 volt here. Time I'm putting as 0 here. This is 0. This is 0. This can be something minus T. This is my V naught T. So when the switch is in the on state, output is your VIT. We talked this in the case of clippers. When VIT is coming, when it is getting clipped like that. So that way, clippers and clampers both will be used in this discussion now. So that's why if doubt is there, you can raise it. I will clarify that. You can go back to clipper and clamper also and explain. The 0 to T switch becomes your on. Now I want this switch to be such that, see, when switch has become off, it is becoming off. Okay, I want to, here I'm putting manual. Manually I'm putting it on, manually I'm making it off. Suppose I make it electrical control. Control signal. This I'm not doing manually. A pulse I have generated, that pulse has come and the switch becomes on. Here it is going by the width of this. Control signal, I'll make it a signal like that. It may be coming at different times. This is my 0. This is my control. Control signal I'm saying as C of T. My control signal is coming like that, C of T. It is very narrow spike. This I can generate from my instrument. Why should I go by this kind of width generation? This width I want to generate or variable values, etc. It will be more troublesome. So instead of that, I generate a clock which is coming as an impulse, or you can say narrow width pulse. Narrow pulse. Pulse train. Pulse train, I cannot say. It is coming in at a different time intervals as a control that I have generated. I made an instrument like that. So when this is coming, switch is becoming on and I'm getting a signal. So what is that? I'm getting a signal here. At this point, I'll be getting from this to this duration only my VIT. I'll be getting here my VIT. This is not the purpose of designing an instrument. Okay, VIT, sorry, VIT. This is not the purpose of designing instrument. I can make this kind of sequence of narrow width pulses, or I call it impulses, of fixed width that I'm not changing. But my control should be according to my this thing choice, how to go for that. So here I'm designing this switch. This is my switch. And control voltage is coming something like that. When the control is here, switch becomes on. Now the control is gone. Still the switch remain in same state, on only. I want it to remain as on. Whenever this has appeared, it remains on. Even if the control has gone, it remains on. So that I call as a stable state of the switch. On state becomes a stable. Stable, I am writing here, stable and unstable. And unstable. These two are states of the switch. Okay, so when it was off, that means VIT was not coming at the output. Okay, that was also a stable state. Unless this pulse was applied, it was in off state. Now when this pulse I have applied, it should remain on all the time till another control signal I apply. So if it remains like that, I call that on state is also stable. Now question comes, how can I make it off state now? So when the next impulse, or you can say narrow width pulse arrives, it will change the state. So it will become off state. Here it was on state, here it becomes off state. So that means from here to here, I'm getting my, here I'm getting like that. I'm making a switch that will give me, I'm writing here, okay. I'm making a switch that will give me this, here the switch becomes on. In this period, I'm getting my VIT. I have controlled with the help of the impulse. I'm getting this one as my VIT. That is from here to here. When this has appeared, it will change the state, and here also it will remain in a stable state unless I bring some other control or disturbance. Next disturbance comes here that I've designed. Okay, so here at this point it becomes again, and here it will go up to this point. That will be my VIT. Because these two are coming side by side. So here it is there, another one is coming here. So it will become off. And after that, no signal is coming. So I can design spacing between the pulses, and I can control when the your input signal is appearing at the output terminal. It has got two stable states, on state and off state. We call it bistable. Two states means bi, and it is remaining stable in both the states. I'll call it stable. I cannot hear. Speak clearly.
At least in the US. बिल्कुल. So basically, car friend को हम जब हमने काम किया.
No, some other sound is coming. Please, control your mic. If the question, I appreciate. So there are two stable states of the switch. I call this switch operation as bistable. There is another one. What we do there, I take some other ink. I think that is better because here only you can see that. Okay. Red color is coming. So another state, another switch I'm designing. This is my impulses. This is my impulses. It may come at regular interval, it may come at any other interval also, doesn't matter. This is my CT, control. There what I make, when this pulse has arrived, this is the switch state I'm saying, switch state. When this pulse has arrived, switch becomes your on. This is your on, this is your off. When it is on, input signal will be coming at the output. It has become your on. And after some time, it will become off. At that time, I am controlling according to my design. It is coming up to this point, not up to this point. This point is somewhere here. So it has started coming like that. So during this interval, I'm getting my VIT coming at the output, but it has become here 0. When the next pulse comes, again it becomes on state, and same width it will come to become your 0. Here it is becoming your on state, coming a 0. Here it is becoming on state, coming a 0. So this is the state. During this time, I am getting VIT at the output. Output is VIT. Here again I am getting VIT. Here again I am getting VIT. So my signal is appearing at the output only during this time interval, and that is controlled by the design of that. So what is there? It has got only one stable state, that is your off. So off state is stable. Stable off state. And unstable. On state. So on state is unstable, off state is stable. So two states are not stable. So we don't call it bistable. Such a switch I will call as monostable, single stable. I'm considering only two states of the switch. Using these two states, you can realize multiple state switches also. That is not there in your subject. Maybe sometimes of your digital design, your teacher will be covering that. So only monostable and bistable. Bistable means both are stable. Monostable means one is stable, other is not stable. Okay. There is a third one, is also, I take it. Yeah, there is a third state here. Not third state, third switch. Here I'm saying these my control pulses, narrow width pulses. Impulse I cannot make, so I call it narrow width pulses. Here is my this and this like that. These are not required. No control will be required. There will be no control in that. Okay. If the any stable state, this CT is required to bring it to some other state. So here no control. No control is required. And here what happens? V output as a switch on, switch state. Switch state, what will happen when I have switched on here, my instrument, my device, okay? It will go to the on state or off state depending on the situation of the environment, not the control, not the design. I cannot design that it should remain in on state there. So environment will make it on state. It will remain on, then it will automatically come to off state. It will remain off, maybe same duration, maybe some other duration. Again, it will become on. On is the same. Here on state is always the same duration. Off state is always the same. Like that. I call this my T1. I call this as T2. So automatically it is coming to that. Starting point, there was some electrical disturbance and that brought it here. So it is not a problem, or you can say some kind of your facility that you are giving in the design of the switch itself. No, only this width I can design. T1 is from here to here, T2 is from here to here. Only this width I can control in the design, and after that it will start fluctuating from this state to this state, this state to this state, something like that. So no state is stable. So we call it astable or non-stable. Astable switch. So what happens during this time? I will be getting my VIT. During this time, I'm not getting my VIT, I'm getting my VIT here again. Okay, so that will be my V naught. VIT 0, VIT 0, and so on. So that way my V naught will be coming. So from this time to this time, from this time to this time, I'm getting my VIT, otherwise I'm not getting that. So that is this is the switch state I have described, and it coming, output is coming like that. When the switch becomes off, it coming like this. So I want to design the switches in which this impulse can make it to on state or off state. According to that, my input will go to the output. Monostable means I'll apply the trigger, it will become on state, and I will be getting output during that particular width that I have designed with the help of your capacitor charging, discharging. And after that, it will come back to your stable state, that is your off state. So that means no output will be coming through the switch. So that is monostable, and astable is simply I have already designed such that during this time I'm getting the output, after that nothing, during this time I'm getting the output. So that is automatic control of the switch, electrically controlled switches. that is astable. Is the question clear? A discussion is fruitful. Okay, this was no control. In astable case, there is no control, but I can control my control signal is not there, but I'm having T1 and T2. This duration I'm controlling by the design. In monostable, I control the period during which my output should be available. Okay, and when it should be available and how long it should be available. Again, it becomes your off. So again, when the say another trigger comes, it becomes your on. Output is available. How long that I have already done, that becomes fixed always. Only same duration will be available. I cannot make it multiple like that. So that you have to make it your piecewise design for your time-based outputs or something like that. That is a different thing. I'm not coming there. Okay, so three things I have done. Any question here? Okay. Now I'm coming to the bistable. You must have read these things in your some digital circuit class also, but here what is happening, what way the control is changing, that was the part of it. Okay. What I'm doing, this is my switch here. And this control signal I'm designing, I know a NOT gate I can write like this. It is not a diode, it becomes a NOT gate. If I apply a pulse here, it will become on during this time. If I apply a gate pulse here like this, it will be on during this time. And when this is connected to this, it will be on during this gate, and this is my Vi, and this is my V naught. Okay? So not gate. When it is like this will be negative rather, not positive, it will be negative. So switch will not be on during this time. Okay? When it becomes negative, here it is positive, here it is negative. Positive means it becomes 0 and pulse I'm taking, so it becomes your 0. When this is your 0 voltage, this will become V volt. This was your V volt, something like that. So 0 and V volt are applying to the NOT gate. This will become a 0 volt when it is V volt here, V volt here. So what will happen? Up to this point, there is nothing there. When it becomes V, here is my 0, here is my T1, and this is my 0 to T1. I have applied the pulse here, switch is operating like that. So it is does it have any stable state? Only one stable state. Can I call it monostable? I cannot control that because I have to apply the width here, same width is going to control that. Okay, so you can say one stable state. And uncontrolled. Unstable state, which I don't want. This is your on state and this is your off state. Okay, so on state and off state coming like that. So I want to change it. So I'll make a latch. Memory I talked in the very first day's lecture with the magnetic memory. Anyway, the similar thing will be emerging here also. What I'm doing, I'm making a NOT gate here. I can put it NOT gate like this. This is the NOT gate. This is my input. This is my output. I am putting another NOT gate. Let me put this way. Okay. Output of this NOT gate, I connect it to this input, and output of this NOT gate, I connect to the input of this. Two NOT gates connected back to back in this loop form. And now I am here. So what happens if I give one input here? Two NOT gates I have applied like this. Okay. So output of this becoming input of this, output of this becoming input of this. What happens when I have switched on the circuit? This is my input. Input is once again control, CT. This CT is controlled as the input. CIT I'm showing as input control. Control input, you can, sorry. I said control input. And this is my C naught T is my control output. Okay, so when control input I'm giving, in a desired manner, if I get the control output and that remains locked to a particular state, that state becomes your stable state. Suppose you make the arrangement, it gets locked to the both the states, on state and off state here at this output. C naught control becomes on and off. This is becoming an on and off. On means its level is high, means high. When I say off, it is low. This is on because it is controlling a switch like this. This switch is controlled by it. So when it is high, switch becomes on. So we call it on state. So output is corresponding to the on state of the switch. And when it is low, output is low, it is corresponding to the off state of the switch that is operating here. The switch is controlled by this. The switch control logic I am generating by this. And this circuit will be monostable, bistable, astable, etc. like that. Is it okay? So this control I'm taking. Now what happens? I have switched on. I don't know what is going to happen to the circuit. So we have to take help of the fact that we are working in an environment where electrical noise is there. So because of the noise, one of the currents will vary. Let us say this becomes your delta I plus original I. I have designed current was flowing like that, based on that something was there. Now this becomes your delta I, it has increased. If it has increased current here, the output will be, it is a NOT gate. So current is increased here, output voltage will be decreased. The decreased output comes here. Input of this. So this output is decreased. It is a NOT gate, so it will increase the output here, output voltage, and that output voltage increase the delta I again. So after that, the noise source is gone. Only once it had disturbed the stability, and it will keep on, that delta I become delta I dash. Now this current has increased. Again, this voltage will be decreased at the output because some resistance will be there in the circuit, internal resistance, whatever is there. So this voltage decreased, this is decreased, this current is increased further, and so on like that. So what happens? This becomes your off state, 0, finally. So if this current has changed, this becomes your off state. Instead of that, somebody can say, sir, my this current is changing, what will happen? Yes, you're right, it will become on state. But which one has changed, I don't know. I have switched on, in few seconds, maybe few milliseconds, it will come to one of the stable states, and this I'm calling as my output. So whatever is the state here, I'm calling that state of the device which is controlling the switch, and this will make the switch off. This is a device instrument. So this device is controlling the switch, and it is in the state that is representing the off state of the switch that is controlling. So it becomes all off. Okay, now I want to change it. This was off state, means it was 0. I apply the pulse here. Pulse that was coming here, I apply here. So this voltage will increase. So this will make it on a state of the device that is going to control the switch. If this is increased, this becomes your off state, low. If this becomes your low, this becomes your high, that is fade back here. So it gets locked. Even if this pulse has gone, only once it has applied, it has decreased. Decrease has come here, it has increased. Now that increase has come here, further it decreased like that, so it will get locked to the on state. This becomes high. Even if this pulse is not there, it remains high. So on and off state. So by single pulse, it has gone transition from off to on. It becomes stable, but that is not our purpose. Our purpose is off to on. Our purpose is that when the second pulse comes, it should be changing the state. So what will happen? When the second pulse comes, it has become an on state now. When the second pulse comes, second pulse I apply here. I have to make the arrangement. Second pulse is applied at this point. So this becomes high. When this becomes high, after that the pulse is gone. This becomes high, this becomes low. This becomes low, this becomes further high and keeps on working as a feedback mode. So this will become off state. So that means I can make it on to off. Second trigger, this is the first trigger. Second trigger is bringing this on to off. Now, question comes, how can I switch on the trigger that pulse is coming from this point to this point? I'm just taking simple example of the NOT gate. I'll come to the transistor circuits and all that maybe very soon, but here it's like that. I'm going to say, how can I change the position of my trigger? Once it is applied here to change the state, next time it should apply here to change the state. So it is bistable, even then I am making these adjustments. So what is that? Yes, this was my NOT gate. This was my NOT gate. This is my output. This is my input. CI, control I am saying. This is my CI. And this is I'm getting my C0. So C0 is to be controlled, and I was applying pulse at this point, pulse at this point. Okay. So when this is 0, it should apply to that. What I'm doing here, I'm making AND gate here. I'm taking this. This was your 1. When this was your 1, I can use NAND gate also, what I'm explaining with the help of the AND gate. When this was your on, the trigger should come here. And this output I'm taking, I'm putting to this point. So trigger I'm applying to that. Another AND gate I'm making. Okay. And this I am putting here. This was your high. It was coming here. I am taking like this. So what is happening when the first pulse comes? See, this was initially, this was C0 was off. Okay. So when the initially it was off. Okay. That means this is your high. When this is your high, when the first pulse comes, this will be high. What about this? This pulse is high, but this was your low. CI was low. So 0 and 1 will give the output 0. So nothing is applied here. So when first pulse comes, first pulse or impulse you can say, first pulse makes it on. Now it has become on, so this becomes your 0. So this output will be 0 till it is 0. So when the second pulse comes, this is 1, second pulse is making it 1, this is 1 at that time, because when the second pulse comes, it has become your on, so this has become your off now, and that's why this is your high, this is your high, so this is output. Second pulse will make it off. Third pulse will make it on again, fourth pulse will make it off. So that's how this bistable circuit I have designed. This is your bistable. I cannot call it a switch, bistable circuit I have designed. Okay, and this C0 is C0 T controls the switch. Switch state. Switch state of the desired switch. The C0 is controlling the switch state. So it is a bistable circuit. Okay. Still, I cannot call it a memory like magnetic one, but it's one step towards that. It is a step towards that. I want to write whenever CI is 1, I want that a 1 should be stored here. Whenever CI is 0, I want this 0 should be stored here. That means your output should be 1 and 0 according to that. So that part I have not done. We call this one as latch. This portion we call it as latch. latch. Latch is your lock. And this is your trigger control. Trigger control. So I defined bistable, astable, and astable, bistable, and monostable. Trigger control is here for bistable case. So any question here? I'll put it clear. Then you can take leave. But today I'm meeting on Friday again. Okay. Any question? Sen Gupta, you're there? Yeah.
Yes, sir.
Okay, fine. So I think I've given the introduction for all the state, all the vibrators, and I'll go for the circuit design for that. Okay, fine. Okay. You check your solution manual and put up questions tomorrow again. I'm listening to that. Thank you. Good day.